Hey guys, good morning. Welcome to the flight dynamics course. Today we are going to see about the wing contribution in stability, especially in static dynamic stability in a stick fixed condition. So already we have derived the overall equation which consisting of wing placement and fuselage and tail placement. The coefficient of moment for wing unknown condition, CMCG is equal to XCA by C into coefficient of normal force plus ZA by C coefficient of adverse force plus CM aerodynamic center. This three terms indicating the position of main wing and its importance. Now we are going to get the stability conditions for wing alone condition. So if you take the rate of change of dCm by dCl with respect to lift coefficient, we are getting dCl by dCl XCA by C plus dCc by dCl into ZA by C plus dCm aerodynamic center divided by dCl. So it is from the definition it represents the zero value because it is acting as an aerodynamic center. So pitching moment is invariant with respect to lift coefficient, or lift moment is invariant with respect to the lift coefficient, and the definition says as aerodynamic center. So this value goes to 0. So remaining these two things we have to derive. So we know the coefficient of normal force is equal to coefficient of lift cos alpha minus z angle plus coefficient of drag sin alpha minus iw. Similarly, the coefficient of adverse force is equal to coefficient of drag cos alpha minus iw minus coefficient of lift sin alpha minus iw. So from this we can get what is dCn by dCl, what is dCl cc by dCl. First you get the dCn by dCl from this equation. So we are getting dCl by dCl, it is goes 1, and we are getting cos alpha minus iw. This is the, so we are going to find out the coefficient of normal force, that is a dCn by dCl. So dCn by dCl from this equation we are getting this is u, this is v. So if you do the dCl by dCl, it will become 1, that is a dCl by dCl, and this is cos alpha minus iw minus, and if you place this Cl, and this is the sin alpha minus iw into d alpha by dc, this alpha term uv method. So plus I write here, so plus dc d by dcl by dcl sin alpha minus iw plus cd cos alpha minus iw into d alpha by dc. This is for this term. Similarly for adverse force, dcc by dcl, we are getting the UV method, that is dcd by dcl into cos alpha minus iw minus cd into sin, it will go plus alpha minus iw into d alpha by dcl. So this term we have got the value, and minus dcl by dcl sin alpha minus iw plus that is cl, that is the sin goes cos alpha minus iw d alpha by dl. So from this we are going to find out this normal force and adverse force, especially dCl by dCl. So all the terms, like here the alpha is very small, and incident angle if you consider as very small, then this term will go as eliminating as 1. Cos 0 will get 1, and sin term will get 0, and cos term will get 1. dCn by dCl will get equal to 1. whereas DCC by DCL, DCC by DCC from 1 by force norm is equal to, we are getting DCD, drag is very, very important in calculating, and minus CL d alpha by DCL. So we are getting these two terms. So now we have to apply this DCN by DCL and DCC by DCL in this wing equation, wing contribution equation, right? So then we will get DCM by DCL is equal to, this force will go as 1, then XA by C plus this term becomes 0, and we are getting DCB by DCL minus CL d alpha by DCL. So here we are getting the position of wing with respect to the CG, which is these terms are drag term, and this is the angle of attack and lift coefficient. But this term only shows us to understand the position of wing with respect to CG. So we are getting DCM by DCL is equal to XA by C. It means the wing position with respect to car indicates where the aerodynamic center located and where the CG is located. Rewriting this term with respect to CG, CM CL equal to XCG minus X aerodynamic center. This is the important note of where the aerodynamic center is located from the CG. The position of aerodynamic center should be aft from the CG, so that you will get a graph, that is the stability graph. That is, this is CM, CG, this is the wing position. So this stable term is a stable term. So wing position, this is the low wing design. This is the high wing design. So from the CG or from the fuselage reference axis, the position of aerofoil, the position of main wing, this is the high wing, mid wing, this is the mid wing. So three position, it is based on the position of CG, says whether it is stable or unstable or unstable. The wing always has stable condition. It represents that the high wing says there will be highly stable comparing with the low wing condition. So we prefer for high wing. It gets the DCM by DCL will get less than 0 by aligning this value from the stability gradient. So this is the overall equation of wing alone case, how the wing helps to design for the stable aircraft or airplane, and the position of car with respect to mean aerodynamic center from the CG represents the DCM by DCL equal to position of CG minus position of X aerodynamic center. So we will see in next class. Thank you.